Good morning, all of you. Today we are going to discuss about the refining process. That's the first one, zone refining. Second one, Mons process. Third, Van Alkal process. Next, we have to discuss about some of the applications of metal. Let us discuss one by one. Please all of you take a note.
Dear children, today our learning objectives to learn about zone refining. The last class we discussed about that refining process, am I right? First one is about that distillation. Second one is about that liquefaction. Third one is about that electrolytic refining. Then two more refining also having. The first one is about the zone refining. This method is based on the principle of fractional crystallization. Here, when an impure metal is melted and allowed to solidify, the impurities will prefer into the molten region. We can discuss how the zone refining process is working. Am I right? First of all, I am taking the impure metal in the form of rod. Okay, I am taking which metal need to purify. That metal I am taking in the form of a rod. One end of the rod is heated using mobile induction heater. This is a mobile induction heater. Okay. What is the meaning of mobile induction heater? Mobile means moving. So, moving induction heater. Okay. So, due to the heating of mobile induction heater, here which result in the melting of metal on the portion of the rod. Suppose I am placing the mobile induction heater in this area. Here what happens? This metal is melt. Am I right? We get a pure crystals, pure metal crystals. Okay, crystallized. What happened? The impurities, this area having some impurities, am I right? These impurities will move to the adjacent molten zone. Okay, that is the nearest place, the next place, the impurities will be moved. Okay, so why? What is the reason? Because due to the movement of heater, I'm just moving the heater slowly. Okay, so when as the heater moves further away, the molten zone containing impurities also move along with the induction heater. Here what happens? When the molten zone containing impurities is also moving along with the induction heater. Anyway, this process is repeating several times by the moving of the heater in the same direction. Again and again, we are doing this zone refining process. We get a purity metal. We get what? A purity metal. Listen all of you. First, what is the experiment here? First, I am taking one of the metal rod. And first here, I am placing the mobile heater here. When I am heating this area, here what happens? Here the metal is crystallized. And what happens? The impurities will be go here. Am I right? Next, I am placing here the mobile induction heater. Here also, due to the heat, the pure metal is crystallized. And what happened? The impurities, this will be moves here. Here also we are keeping the mobile induction like that. If you are doing further and further and further several times, we can be achieve a pure metal. Okay. Here, what are the examples of this zone refining means? Number one, germanium. What is the first one example? Germanium. The symbol of germanium, Ge. Next one, silicon, Si. Next about the gallium, Ga. These are the three examples. Okay, and also he is used as the semiconductor as refining using this process. Okay, element. These are the elements. They can be used as a semiconductors. All of you know that on silicons we are using the semiconductor, am I right? Including germanium and gallium also used as a semiconductor. Okay. And one more important point, this process is carried out in the inert gas atmosphere. Okay. So what is the reason? Means to prevent the oxidation of metal. What's the meaning of inert gas atmosphere? Inert gas, all of you know that on helium, neon, argon, krypton, xenon, radon, am I right? The 18th group metals are called as inert gas, am I right? Yes or no? Inert gas atmosphere. Here, the atmosphere is mostly content is about the air, am I right? Air means we know that one, which are the common and present in the air. We know that 78% of nitrogen and 21% of oxygen, am I right? So, here one of the possibility for contaminating the air, am I right? Because the air having the oxygen. So here also having, such germanium, silicon and gallium. So what happen when the air oxygen combines with germanium, we get germanium oxide, am I right? Like that silicon oxide and also gallium oxide. So to avoid this one, we are taking the inert gas atmosphere. Okay, this process is carried out where? In the inert gas atmosphere. Okay, so try to learn this question. Next one of the very important question about that, vapor phase method. Vapor phase methods, very, very important question. Here, what is that one? The metal is treated with a suitable reducing agent. Here, the metal is treated with a suitable reducing agent to form a volatile compound of a metal. We get one of the volatile compound with the metal. That compound containing the metal. What is about the volatile? Easily evaporating substance. Okay. Easily evaporated substance is called what? Volatile compound. Am I right? So anyhow, this volatile compound is obtained with the metal. So next what happens? The volatile compound undergoes a decomposition. We get pure metal. So first condition is metal combines with one of the suitable reagent, we get one of the compound that may be a volatile compound. This volatile compound again undergoes decomposition, we get and pure metal and respective reagent. Am I right? Here we are using one of the process is called Mond process. Very, very important question. Mond process. Okay. Here we are taking in purification of nickel metal. Okay, nickel. Don't forget that. The impure nickel is heated in a stream of carbon monoxide. So what is the symbol of nickel? Na. Am I right? Na on reacts with, on treatment with, or heated with carbon monoxide. What is the formula for carbon monoxide? CO. Am I right? About the temperature is about 350 Kelvin. What is the temperature? Don't forget, it's very, very important. Try to learn the equation now. Okay, you must learn the equation now. Nickel, what is the symbol of nickel? Ni. What is the formula of carbon monoxide? CO. So what's the temperature is there? 350 Kelvin. We get one of the compound. Which compound? Volatile compound. Okay. Volatile compound with the metal. So we get nickel combines with the carbonyl. That is carbon monoxide. It can be say carbonyl. Okay. Tetracarbonyl. Okay. We get NiCO4 times. NiCO4 times. This is one of the gaseous molecule. Okay. Gaseous. And carbon monoxide is one of the gas. And also nickel is a solid state. So what is the compound here? Nickel tetracarbonyl. Nickel tetracarbonyl. Okay. So how much carbon monoxide is there? 4. So make it 4 here. Now the equation is balanced. This is one of the volatile compound with nickel. Okay. Next. Here, this volatile compound with the metal, that is with the nickel, on heated around. Okay, that means we can be written as tetracarbonyl, nickel tetracarbonyl. What is the formula? NiCO 4 times. Okay, this is one of the gaseous state. Undergoes with 460 Kelvin temperature. So here decomposition takes place. What takes place? Decomposition takes place. Don't forget the temperature. Okay. Nickel, we get the solid plus carbonyl, that is CO, carbon monoxide. How to balance the equation? Here 4CO is there, so make it 4CO. This is one of the gas. Okay, gas, nickel is a solid. Okay, so don't forget that. It's a very important. Only the two equation is enough. Okay, try to learn the two equation. That is about the nickel on heated with the carbonyl. That is carbon monoxide. We can be say carbon monoxide. We get nickel tetracarbonyl. What is the formula? NiCO 4 times. And what is the temperature? 350 Kelvin. Next, nickel tetracarbonyl undergoes a decomposition at the temperature is about 460 Kelvin. We get a pure nickel metal and also carbon monoxide. We have to balance 4. Okay, this is about the Mond's process. Next about that, Van Alkal method for the refining of Sirgonium, okay, or titanium. So we are using Sirgonium or titanium. So as per our textbook, we have only titanium. So try to learn this titanium. Okay, here this method is based on the thermal decomposition of metal. Thermal decomposition. What is the meaning of thermal decomposition? That means by applying heat, this metal undergoes decomposition. Okay. And also decomposition of metal compounds, which leads to the formation of pure metal. The same process only. Here we are taking titanium and Sirgonium. What is the formula for titanium? That is about the Ti, and Sirgonium is ZR. Am I right? But our textbook we have only titanium, so I am taking titanium, Ti, titanium. Okay, the titanium. This I am treatment with the iodine. Iodine. What is the symbol of iodine? I2. Am I right? This on heating. What is the temperature? 550 Kelvin. What is the temperature? 550 Kelvin. On heating we get a volatile titanium tetraiodide. A volatile titanium tetraiodide. Okay, one of the volatile compound, titanium tetraiodide. So formula is TiI4, titanium tetraiodide. Temperature 550. Very, very important. Okay. So the impure titanium metal is heated in a evacuated vessel. What is the meaning of evacuated vessel? One of the empty vessel. Okay. That empty vessel with iodine. What's the temperature? 550 Kelvin. To form, we get a volatile compound, easily evaporating compound, volatile compound. What is the compound there? Titanium tetraiodide. What is the formula? TiI4. Okay. So, the impurity is left behind and they do not react with iodine. They have some impurities. It is left behind. They will not react with iodine. So, we get the titanium tetraiodide vapor is passed over a tungsten filament. We are taking one of the filament called tungsten. Okay, tungsten filament. Okay, that means a heated tungsten filament. The volatile titanium tetraiodide vapor is passed over a titanium filament. That's a heated titanium filament. What is the temperature? Is around 1800 Kelvin. Don't forget the temperature. Okay. So these are all very important one-word question. Try to learn the temperature thoroughly. Okay. Anyhow, the volatile titanium tetraiodide vapor is passed over a heated tungsten filament at the temperature is around 1800 Kelvin. So, first you have to write the equation. titanium tetraiodide formula TiI4. This is a vapor state, vapors, and what is the temperature is there? 1800 Kelvin. We are heating the temperature. So we get the decomposition. What is about the decomposition? Titanium tetraiodide is decomposed, separating, decompose with pure titanium. What is the formula here? TiS, that is a solid state. Pure titanium and also we get iodine. Here, the pure titanium is deposited at the tungsten filament. It is deposited where? In the filament. Okay, what about that iodine? Iodine is recreated. Then we can be used. Reused. Okay, we get the iodine also. So how to write the equation? Titanium tetraiodide vapor on heated with 1800 Kelvin, we get titanium plus iodine molecules. Okay, we have to balance the equation. How much iodine is there? In the reactant side we have 4 iodine. So the product side we have to mention 4. That is 2 into 2 is equal to 4. Now the equation is balanced. So anyhow, my dear children, try to learn thoroughly the Mond's process and also one Alkal method. These 2 processes you have to learn thoroughly, and also zone refining also a very important question. The 3 equation is over. Next, about what are the applications of metal? Okay, what are the applications of metal? Here we have the aluminium metal, zinc metal, iron metal, copper metal, gold metal. Have 5 types of metal. So we can be discussed one by one. Okay, applications of metal. First applications of metal is aluminium. What is the symbol of aluminium? Al. Okay, the aluminium is the most abundant metal. Okay, it's a most abundant metal. Okay, and it is one of the good conductor of heat and electricity. It's one of the good conductor of heat and electricity. It is also resist corrosion. Okay, what is the meaning of corrosion here? Destroying the metal by chemical reaction. The metals are destroying by means of chemical reaction. That we are saying corrosion. Okay, anyhow, here we have to learn about what are the applications of aluminium metal. First point about that, the many heat exchangers and our day-to-day cooking vessels are made up of aluminium. That means heat exchanger, sink, these are all, and our cooking vessels. Okay, we are cooking some vessels. Am I right? These are everything are made up of aluminium. Second point, the aluminium is used as a wrap. That means covering the food materials. Okay, covering the package of materials for food items. Okay, that is used as this type of an aluminium is used for the packing materials of food items. The third one is aluminium is not very strong. Okay, and its alloy. What is about the alloy? What is the meaning of alloy? Alloy means the combination of 2 or more metals. The combination of 2 or more. What is the reason? Aluminium is not a strong metal. Okay, anyhow, its alloy, aluminium alloys. Alloy means combination of 2 or more metals with aluminium with the copper or manganese or magnesium and silicon. These are all called what? Alloys. Okay, they are lightweight and strong. They are used in the design of aeroplanes and form of transport. Many transport vehicles also nowadays we are using the aluminium. Okay, next fourth point about that. And aluminium show high resistance to corrosion. It is used to design the chemical reactor. Can you say on chemical reactor? That means one of the chemical reaction carried out some of the reactor means we can be taken as petrochemical reactor. Okay, petrochemical reactor. Next about the medical equipments. What is about the medical equipments? Medical equipments means you know that about the MRI scan and the CT scan. These are all about the medical equipments. I mean, this is made up of an aluminium. Okay, Next about that gas pipelines. What is about the gas pipelines means? That means the transmission of gaseous materials. Gaseous materials means can be say that natural gas, some of the gas are going the transmission. Okay, it is about that gaseous pipelines that is used. Next about that aluminum is the good electrical conductor. One of the good, already we discussed that it's a good conductor of heat and electricity, am I right? So aluminum is a good electrical conductor and cheap. Okay, hence it is used in an electrical overhead electrical cables and steel core for strength. These are some uses of aluminum. Try to learn, my dear children. Any 3 or 4 point is enough. Okay. Try to understand the concept. Next one about that applications of zinc. A very, very important application is about the zinc. Okay. The metallic zinc is used in a galvanizing metal such as iron and steel structures to protect them from the rusting and corrosion. What is the meaning of galvanizing? Galvanize means one of the metals we are coating with the zinc metal. Okay, one of the metal we are covering with the zinc metal. Otherwise, we can be say coating with the zinc metal. That process we are saying galvanizing metals. Okay, such as iron, steel, sir, protect them from rusting. All of you know about the rusting and about the corrosion. What is about the corrosion? Destroying the metal by chemical. Okay, chemical action. Okay. Next about zinc is also used to produce die casting in the automobiles, electrical and hardware industries. Zinc is also used to produce die casting. What is the meaning of die casting? Make the molten metal into molding purpose. What is the meaning of molding? Molding means we are creating one another equipments. Okay. So make the molten metal into molding process. Okay, that's you are saying die casting. And about that automobile means all of you know that one. That is a motor vehicle. Am I right? And the electrical and hardware industries. Okay. Then zinc oxide. That applications of zinc we are learning now about the zinc oxide. It is used in the manufacture of many products such as paint, rubber, cosmetic, and pharmaceuticals, plastic, ink, batteries, textile, and also some of the equipment, electrical equipment. Okay, pharmaceuticals means what is the meaning of pharmaceuticals? Making some medicine. Plastics, ink, batteries, textile, and also electrical equipments. And also one more the important point, zinc sulfide. Zinc sulfide. What is the formula of zinc sulfide? E13. Yes, zinc sulfide is used in making luminous paint, fluorescent light, and also X-ray screen. What is about the luminous paint? Some of the paint is very shining. Am I right? It is very shining and also glowing with light like that. Very, very important. That is the luminous paint. Glowing with light. Okay. Very nice paint. Okay. Am I right? Next about the fluorescent light. What is about the fluorescent light? Low fluorescent light is one of the light, low pressure mercury vapor lamp. Okay, it will be produce the visible light, one of the visible light. Next about the X-ray screen, all of you know that one. These are all used as a zinc sulfide. Next about the brass of alloy. Brass of alloy is used to water walls and communication equipments. And some of the communication equipments, and also it is highly resistant to corrosion. These are all applications of about the zinc. Am I right? Next about that applications of iron. What are the applications of iron, dear children? Here, iron is also very important nowadays. We know that in the building construction. Am I right? These are the many items about the iron. But here, the iron is the one of the most useful metal. And its alloy, iron alloy, are used to anywhere including bridges. Am I right? Bridges, electricity, pylons, bicycle chain, cutting tools, and rifle barrel. These are all some examples about the applications of ions. Here means all of you know bridges. Am I right? Bridges we are using, buildings, bridges we are using with the help of ions. Am I right? Electricity pylons. That means some of the electricity having a tall metal tower. Did you know about the metal tower like that high tower? cell phone tower like that, the electricity towers. These are all used. These are all other applications of ions. And also our cycle chain, bike chain. This is all, everything is made up of iron. Am I right? Next about the cutting tools, some of the cutting tools and rifle barrels, weapon items. Some of the weapon items also made up of from ions. Okay. Next about that, cast iron is used to make pipes, valves, and also pump stoves. Some of the stove. This is a old method, pump stoves. Okay, nowadays not having. Okay, before the last years we have the pump stove. These are the uses of applications of iron. Next also, the magnet can be made from iron. Our magnet, ordinary magnet is also made from iron, and its alloys and compounds. And very, very important point, one of the very important point, and important alloys of iron is a stainless steel, am I right? It's a very application, stainless steel, okay. And it is very resistant to corrosion. It is used in the architecture and bearing, cutlery, surgical instrument, and also jewelry, okay. These are all the application. That means bearing. Bearing means no, but that is one of the minerals of iron. One of the minerals of iron. What is about the cutlery? Cutlery means one of the knife with and spoon, like one of the spoon-like appearance. It is used for eating purpose. Am I right? Next to surgical instrument. All of you know that one. Next about jewelry. Jewelry also some of them are using. And nickel steel is used for making cables, automobiles, and aeroplane parts. Okay, here nickel steel, one of the steel is made from iron. It's also you making for cables, automobiles, and also your aeroplane parts. So very important about that. Chrome steel. What is the use of chrome? Is one way question. Chrome steel are used for the manufacture of cutting tools and also crushing machine. Crushing, what is the meaning of crushing? Powdering. Okay, the ores are powdering, am I right? For the powdering, we are using that iron. Okay. Try to learn at least, my dear children, 3 points enough. Try to read that one. Okay, some of the important concept. Next about the application of copper. All of you know about that applications of copper. Copper is the first metal used by the human. Am I right? Copper is the first metal. Okay, and the extended use in the alloy bronze. What is about the bronze? It is a mixing of tin and copper metal. Okay, bronze means one of the metal that is a mixture of tin and copper. Okay. Copper is also used for making coins, ornaments, along with the gold and other metal. Copper also nowadays it is a very costly also. It is also used for making coins, some of the coins, ornaments, and also gold with other metal. Am I right? And also copper and its alloy. Copper alloy. Okay, copper alloy is used for making cable wires, water pipes, and other electrical parts. Nowadays copper are using. Next about the very important application is about the gold. Okay, all of you know gold is one of the precious metal, am I right? And it is an expensive one, and it is used as a coinage and has been a standards for monetary system in some other countries. That is connected with the money. Connected with the money items. Okay, it is one of the expensive and precious metal used for the coinage. Okay, next about it is used in a jewelry. Okay, in the alloy form with the copper. Okay, gold are using in jewelry in the alloy form with the copper. It is also used as the electroplating. That is about that gold electroplating. To covering the metal. What is about the electroplating? By means covering the metal. Okay, covering the metal in a thin layer of gold. Some of the watches also, some watches are so covered with the gold. Am I right? That's a gold watch. We are saying like that, gold watch. Am I right? Gold watch covering with a small amount of gold, and also artificial limb joining. What is about the artificial? It is not a natural, artificial limb. Limb means we can be say as a bone joint, okay. And also cheap jewelry. Cheap jewelry means, you know about that one. That is, I think that about that it is a duplicate ornaments, okay, one of the duplicate like that ornament. And also dental filling and also electrical connectors. These are all is made up of what? They are gold. Next is about that gold nanoparticles. Gold nanoparticles is also used for increasing the efficiency of the solar cell. Do you know about the solar cell? Some of the solar cells are in our watches, calculator, everything have, am I right? So gold nanoparticles. What's the meaning of nanoparticles? Nano means we can be say micro. It's a very, very minute microparticles are used to increase the efficiency of solar cell. And also this also nanoparticles, so gold nanoparticles are used as a catalyst. My dear children, what is about the catalyst? Catalyst means it is one of the substance which will be increase the rate of the reaction or decrease the rate of the reaction. Okay, one of the substance we are using a catalyst. One of the reaction can be done, we are using one catalyst. Okay, that may be increase the reaction or it may be a decrease the reaction. That less we can be discuss about the catalyst in our next lesson. Okay, next lesson means not next lesson. We have another one lesson. That time we can be discuss about what are the catalysts about that. Okay, so my dear children, today our learning objective is to learn about that the zone refining is a very, very important. Try to learn the zone refining. What is about the zone refining? First of all, in this process, the impure metal is taken in the form of rod. Am I right? One end of the rod is heated with a mobile induction heater. Am I right? So due to the heat, the result melting of the metal to one portion to other. Am I right? When the heater is moving one portion to other, what happened? The purity of the rod is increasing. Okay, so impurities will be left out. Am I right? That process we are taking. What are the examples here? We are taking germanium, silicon, and gallium. Okay, these are some examples. They are used as a semiconductor. Don't forget that. And also, this process is carried out in an inert gas atmosphere. Don't forget, that's an important point. This process, this zone refining process is carried out in an inert gas atmosphere. For what purpose? To prevent the oxidation of metal. To prevent what? The oxidation of metal. And also, this method is based on which principle? That is about the fractional crystallization. Some of the very important one words. Next about that. Bond process, all of you know that one. The bond process. Try to learn the equation thoroughly. What is about that? Nickel combines with carbon monoxide. What's the temperature here? 350 Kelvin. Don't forget that. 350 Kelvin we get nickel tetracarbonyl. Next, again, the nickel tetracarbonyl undergoes heating at the temperature is about 460 Kelvin. We get nickel, pure form of nickel, and also we get the carbon monoxide. Next, about the Van Alkal method, the refining of zirconium and titanium. We are taking the titanium. The impure form of the titanium is taken in a solid state and combines with the iodine. We get titanium tetraiodide. It is one of the volatile substance. What's the meaning of volatile substance? Easily evaporating substance. Am I right? So titanium tetraiodide. Tetraiodide. What is the formula? TiI4. Titanium tetraiodide. One is a volatile, easily evaporating. Next, again we are going to heating. That is a decomposition. What's the temperature is about? 1800 Kelvin. We get titanium and also iodine. Next, about the application. Try to learn the application part. At least three points. Okay, try to learn. Anyhow, today, our assignment. I'm giving the assignment. What is about the assignment means? A small 3-mark question. Try to learn, my dear children. Try to learn and write the assignment. First one is about the Mond process. Mond process means I am expecting only the equation with the temperature is enough. Okay. Don't forget to write the temperature. Equation along with the temperature is must. And write the name also. For example, NiCO 4 times means nickel tetracarbonyl. How to write like that? Okay. Next, Next temperature is about 460. Write the two equation, Mond's process, and also about the one Alkal method, also the refining of Sirgonium and also titanium. You have to learn about the titanium is enough. Okay, write the titanium equation. Only the equation part is over. Okay, try to learn and you must thorough the temperature. So first assignment is Mond's process. Second assignment is Van Alkal method. Third one is about that zone refining. Zone refining, one of the 3 mark question. Okay, try to learn the 3 question and send to me. Okay, thank you all of you. Thank you. Have a nice day.